Okay, guys, so we're on to page 14, talking about electromagnetic energy. Remember that this is what we've talked about in our previous unit, so it's kind of a little bit of review. If you didn't learn or remember the electromagnetic spectrum back in the previous unit, make sure you're learning it now. So electromagnetic energy travels in the form of waves. A wave is a disturbance in matter that transmits, means sending out energy. Remember, if I hit my desk, I'm not throwing matter everywhere. Pieces of my desk aren't flying. You're hearing it as sound because it's transmitting that energy. Electromagnetic energy can travel in the form of radio, visible light, UV, and other waves. You have learned that thermal energy can be felt in the form of heat. Okay, moving. Electromagnetic waves can also warm objects. Example, you can feel the sun's heat. It is losing energy as heat. Temperatures, measure of the heat of an object. So it tells you how hot it is or not hot it is, because there's no such thing as cold. So electromagnetic waves and temperature. Light warms an object. So the amount of temperature increase is related to the light intensity. Do you have a 60-watt bulb, 120-watt bulb? Those produce more heat. The length of time the light shines on it. Is it on it? Did you turn it on for 5 minutes? Has it been on for 5 hours or 5 days? That all tells you difference on how hot the bulb can be and how much light is absorbed. Remember, different colors absorb different amounts of light. Black absorbing all the light, it's the color that you would feel the hottest in. So we're not going to do this, but I want to discuss this. Place 2 separate objects in a sunny area, a dark colored object or a light colored object. After 15 minutes, I want you to record your observation for each object and describe why there is a difference between the two. This is something you can do at home. Take a black t-shirt and a white t-shirt. Your school colors, navy and white. Go outside, put them both outside in the sun, and then after 15 minutes, go outside and see what is the difference. It could be paper. It could be, just pick something, dark and light. And then what would you notice? So if we're going to discuss this, but think about it. Usually the darker color object is going to feel warmer than the lighter color object because it's absorbing more sun or more light. So 2 things that we're going to talk about: transmission, refraction, and reflection. We've talked a little bit about these. We're going to kind of review it. So transmission of light occurs as light passes through something. Eyeglasses transmit more light than sunglasses. So transmission is kind of the difference between transparent and translucent. And opaque. How much light is going through? So that's a picture of the sunglasses. You see the sun is not coming through completely as in the other picture. Transparent allows all the light to go through. Translucent scatters the light, and opaque blocks the light. So how much light is going through transparent or translucent? Refraction of light occurs when light is bent as it enters a substance and changes paths. It's changing the medium. So this light here is going through a gas. It's the air. It's the surrounding air. It hits the prism. A prism is a solid. It changes. Notice it bends here a little bit, and then it bends as it goes out because it's going back to a gas. Light travels fastest in a gas and slowest in a solid. Because of that, you're changing the speeds of how fast it's traveling. And remember, it's always fast. And then reflection of light. Light is not absorbed, taken in. It may occur as, light is not always absorbed. It's not always taken in. It may occur as light is scattered and dispersed as a color. The reason the sky is blue. The light is shining and there's a bunch of water droplets in the air and they're being dispersed, and that is why you see the sky as blue. If it's absorbed, you don't see it at all. And reflecting, it comes back at you like a mirror. A mirror is a solid. You can't see through it, but the light does come back at you. So it's being dispersed. All right, we'll pick up with the other stuff later. Have a good one.